our Christmas worksheet. Let's start with exercise number 1. Aluminium with the symbol Al is a good electric conductor, malleable and of density 2.7 gram per centimeter cube. A piece of aluminium has low mass compared to its volume. Aluminium is used in the beverage industry. It is non-toxic, odorless, tasteless, light in mass, and the liquid inside the container can be cooled quickly. Document 1 shows the transformation of aluminium atom into ion. Aluminium atom with the chemical symbol Al and mass number 27 has X electrons outside its nucleus. If an aluminium atom loses 3 electrons, it becomes an ion. Given the relative charge of each proton, it's 1 plus, and the relative charge of each electron is 1 minus. Question number 1. Identify the nature of aluminium ion, cation or anion without calculation. The nature of aluminium ion is a cation, since when an atom loses a certain number of electrons, it will become a positively charged cation. Question number 2. Determine the composition of aluminium atom. Composition means you need to calculate the number of protons, electrons, and neutrons. According to document 1, number of protons is given. They are equal to 13. Since atom is electrically neutral, number of electrons it's equal to the number of protons, it's equal to the atomic number, it's equal to 13. And you have the mass number A equal 27, it's given for you. So we can now calculate the number of neutrons, which is capital letter N, using the following relation. A equal Z, which is the atomic number, plus capital N, which is the number of neutrons. So N equal A minus Z, number of neutrons will be equal to 14. So the composition of aluminium atom, it contains 13 electrons, 13 protons, and 14 neutrons. Now question number 3. Deduce the composition of aluminium ion. When an atom is converted into an ion, you have to know that only the number of electrons changes. Number of protons and the number of neutrons remains the same. Here in this case, aluminium atom loses 3 electrons, it becomes an ion. So the composition of aluminium ion will be number of electrons. Since it loses 3 electrons, so we can say that it's 13. Initially we have 13 electrons minus 3, it's equal to 10. Number of protons remains the same as in the atom, it's equal to 13. Number of neutrons also remains the same, it's equal to 14. Now moving to question number 4, calculate the charge of aluminium ion. To calculate the charge of an ion, it is equal always to the total charge of protons plus the total charge of electrons. To calculate the total charge of protons, it's equal to the total number of protons inside the ion times the relatively charge of each proton, which is 1 plus the total number of electrons times the relative charge of each electron, which is 1 minus. So here, inside the aluminium ion, number of protons remains the same, they are 13. So we have 13 times 1 plus, which is the relative charge of each proton. It's equal to 13 plus. Then we add to it number of electrons, it's equal to 10 times 1 minus 10 minus, so we have here that the charge of aluminium ion is equal to 3 plus. That's why the chemical symbol for the aluminium ion can be written as Al 3 plus. Question number 5. Write in an equation form the above transformation, means from atom to ion. So we can say that aluminium Al gives Al3 plus, this is the ion, by losing 3 electrons. So we write here plus 3 electrons. We have the electrons after the arrow, since aluminium atom loses 3 electrons. Question number 6. Indicate why aluminium is an ideal metal used in the industry for making beverages cans. Referring to the text, aluminium is used in the beverage industry. It is non-toxic, odorless, tasteless, light in mass, and the liquid inside the container can be cooled quickly. Now moving to exercise number 2 about nitrogen atom. Nitrogen is a chemical element with the symbol capital letter N. It is a transparent and odorless gas that constitutes the largest part of the Earth's atmosphere. It contains 7 neutrons in its nucleus. Document 1 shows the schematic representation of nitrogen atom. Given the relative charge of each electron, it's 1 minus. Number 1. Indicate the number of electrons in nitrogen atom. Referring to document 1 here, if you count the gray dots, they represent the total number of electrons inside the electron cloud. So the number of electrons is equal to 7. Question number 2. Reduce its atomic number. Since atom is electrically neutral, number of electrons, which is 7, equal number of protons equal to the atomic number, it's equal to 7. Number 3. Calculate its mass number, capital letter A. We can use directly the relation A equals Z plus N. So mass number A is equal to 7, atomic number plus the number of neutrons, which is given for you. So mass number equal to 14. Now moving to question number 4. Write the symbolic representation of nitrogen atom, or the atomic symbol. It's written in this way. We write the chemical symbol in the middle, which is capital letter N. We write the mass number, which is 14, as an upper subscript to the left, and the atomic number as a lower subscript also to the left side. Now, number 5, calculate the relative charge of the electron cloud of nitrogen atom. The relative charge of electron cloud is equal to the total number of electrons times the relative charge of each electron. So here we have 7, which is the atomic number, times 1 minus the relative charge of each electron. So we can say that the relative charge of electron cloud for nitrogen atom is equal to 7 minus. Now moving to question number 6, nitrogen atom now gains 3 electrons to be stable and becomes nitride ion. 6.1. Translate the above statement into an equation form. So we can say that nitrogen atom with the symbol capital letter N plus 3 electron, since it gains 3 electrons to give N3 minus. 6.2. Indicate the type of the corresponding ion. It's an anion, which is negatively charged. 6.3. Determine the composition, which means the number of protons, electrons, and the neutrons of the nitride ion. Now, since nitrogen atom gains 3 electrons, it becomes an ion. So the number of electrons will be initially 7 plus 3. We will add 3 electrons. So the number of electrons is equal to 10 inside the nitride ion. Number of protons and number of neutrons, they will be equal to 7. They remain the same. Number 7. Fluorine atom has 2 more protons than nitrogen atom, and its mass number is equal to 19. 7.1. Determine the atomic number of a fluorine atom. Number of protons in a fluorine atom will be 7 plus 2. It's equal to 9. Atomic number, it's equal to the total number of protons. It's equal to 9. Question 7.2. Deduce the number of electrons and the neutrons in the fluorine atom. Since atom is electrically neutral, we can say that number of electrons equal number of protons, it's equal to the atomic number, it's equal to 9. Now using the relation A equal Z plus N, we can calculate the number of neutrons, which is equal to 19 minus 7, it's equal to 12. Now moving to exercise 3, which is about periodic table. Document 1 shows a section of the periodic table. Given relative charge of each proton, it's 1 plus. Question number 1, determine the relative charge of the nucleus of a neon atom. In the modern periodic table, elements are arranged according to their increasing order of atomic number. So looking here at document 1, for hydrogen we have Z equal 1. Moving here to helium, Z equal 2. Moving to lithium, we have Z equal 3. And so on to reach neon, Ne, which will be equal to 10. So the atomic number of neon will be equal to 10 according to the given information. So for neon, atomic number equal 10, it's equal to the total number of protons. Now to calculate the relative charge of the nucleus, it's equal to the total number of protons times the relative charge of each proton. So it will be equal to 10 minus. Now question number 2. Justify whether oxygen is a metal or a non-metal. Oxygen is a non-metal since elements that are located to the right of the stair-step line are non-metals. So this is the non-metals region. Question number 3. Referring to document 1 again, answer by true or false, justify the true statements and correct the false one. 3.1. The second alkali metal is sodium atom, Na. Looking at document 1 is true since sodium belongs to column 1, alkali metals family, row 3, and here we have hydrogen is an exception. It doesn't belong to alkali metals family, it is a non-metal. 3.2. The element that just follows neon in the periodic table is argon. It's false. We can say that the element that just follows neon in the periodic table is sodium. So after neon, moving to the third row, we have sodium Na, not argon. Or we can say that the element that just below neon in the periodic table is argon with the symbol Ar. 3.3. The element that follows beryllium, Be, in the periodic table is boron with the symbol capital letter B. It's true. Looking at the table here, we have Be, then we have boron. Since the element that follows beryllium with Z equal 4 in the periodic table is boron with Z equal 5. Now 3.4. The element that has an atomic number equal to 15 is phosphorus. That's true, since in the modern periodic table, elements are arranged according to their increasing order of atomic number. So, if you count the atomic number here, moving to phosphorus, you will find that the atomic number of phosphorus is equal to 15. 3.5. The atomic number of the second halogen is 19. That's false. Looking at the periodic table here, the atomic number of the first halogen, which is F, is equal to 9 halogens. They are located in column 17. So here the first halogen is a fluorine. Or you can say that the atomic number of the second halogen is equal to 17, not 9. Now moving to exercise number 4, the ion with the atomic symbol XAZ and with the ion charge 2- has the same electron configuration as the second noble gas. Number 1, write the electron configuration of the second noble gas, which is located in column 18, row 2. So the electron configuration of the second noble gas will be K2L8. Number 2, deduce the electron configuration of the ion X2-. It will be the same as the second noble gas, so it will be K2L8 again. Number 3, determine the number of electrons in this ion. So you have just, you need to count 2 plus 8 to calculate the total number of electrons, so it's equal to 10. Now, for question number 4, determine the atomic number and the mass number of the initial atom XAZ, knowing that it has 8 neutrons in its nucleus. The number of electrons in X atom is less than that in X2 minus ion by 2. So we can say that for X atom, number of electrons equal 10 minus 2 is equal to 8. Since atom is electrically neutral, number of electrons equal number of protons, it's equal to the atomic number, it's equal to 8. For the mass number, we will use the relation A equal the Z plus N, so it will be equal to 16. Please be safe and keep up the good work. Thanks for watching.